Alright, 10.2, a new section. What we learned yesterday. We learned about radicals and roots, basically, special name for it. We learned how to compute any kind of index. We call it nth root of any number and expressions. How you simplify them or how you compute them. Okay? There are a couple of challenges, soft points we need to touch, but we will repeat that whenever we need to recall something. I will go back and repeat. Today we are going to compute rational exponents. What does rational exponent mean, by the way? Look at the first four letters. Ratio. Everybody knows what an exponent is, right? This is called an exponent. Power. But what kind of power is that? What kind? Is that a whole number? No, it's a ratio, 1 over 4. That's what we mean rational exponents. We're going to compute if everything is a number, we will compute them, and sometimes we just need to simplify them because there are variables. We will just learn how to change them today, how to manipulate them. Okay? But before that, I'm just wondering how you guys compute powers, such as what is 4 to the 5th, for example. How do you guys compute this? But this 5th power means you repeat the base number how many times? 5 times. You just one by one multiply this, right? 16, 64, one more 4 makes 256, and then one more 1024. Is that right? That's how you multiply. Correct? Am I right? No, 1016. I'm not good at that. Okay. 1016. That's how you compute it. Question is, what if I flip this 5 into a ratio, not whole number anymore, 1/3? Is the same reasoning works? Should I just multiply this by 3 times itself? I see 3. Oh, I see 1 over. Are we gonna make 1 over? Because I see this kind of solutions in the exam. Now this looks like intuitive, reasonable, but mathematically incorrect. So just because you have 1, you don't put 1 over here. It's a complete new idea. Alright? So how do we compute them? Here is the formula. This is what you need to convert. If you see 1 over a whole number, 1 over n above a base, any number or expression, you turn it into a radical or prison, we called it yesterday, right? We call it into prison, and the guard of the prison is n. Let me just make this bigger, it's too tiny. Again, when you see 1 over something, it turns into prison with index n, and prisoner, whatever the base is, a. So you know what to do with the first question then. To compute 16 raised to the irrational power exponent is, make the prison, put 16 in it, and decide the guard. Who's the guard? Oh, perfect. Oh, are we gonna leave it like that? No, we just converted it into radical form. The first half is done. We need to now simplify it. Simplify means yesterday. This is yesterday, 10.1. You just need to understand what 4th index radical prison means. That means find the number. You're going to find the number here. You multiply it 4 times itself, and it turns into 16. Is there such a number exist? Check. Is it 1? 1, 1, 1, 1 is not 16. Is it 3? 3, 3, 3, 3 is 27, 81. 81 is too much. So back up. How about 2? 2, 2, 2, 2 is 16. Yeah, there you go. You got it. Oh, they want radical form first. There you go. I make it 4, 16. It's a real number. Yes, we found it actually. It's 2. Because sometimes this thing is not computable, and you know when it's not computable, right? Yesterday. By the way, when is this not computable? Anyone can recall? Remind us. When can you not compute a radical with index 4? If its inmate is a negative, we cannot compute. If the guard is even. Odd numbers, odd index, odd guards are fine. They compute everybody, but even ones are only accepting positive inmates. Alright, let's proceed. How about this guy now? First, alright, there is it looks like identical questions, right? They didn't do much change. There is a tiny little point here, very dangerous point actually. You can make a mistake here. I think most of you guys are gonna make a mistake. That's my claim, I don't know. Alright, give it a shot and tell me your answer, please. Tell me. We can't find it out, right? It's not a real number. Why? Because it's negative. Alright, let's do it. Right? Do you all agree? Anybody comes with a different answer, say it or before too late. So our verdict is, our common sense says, this is a negative number. This is gonna put under a prison of guard 4, even index.
I think it's -3. I think it's -4.
Okay, it says -4. We say not a real number. Any different answers? My intuition says it shouldn't be a number because it's negative. Okay, here is one point we are missing. Look, 1/4 exponent, right? So you think we have 4 here, the guard, 256 with a negative inside, correct? Correct? If the question would look like this, yes, we are right. This is not a real number because we cannot compute even index radical of negative numbers. Even numbers and negative numbers don't get along. We're right. However, take a deep look at, please. I want to enlarge this. Versus compare this. Tell me the difference. Are these two things the same? Are they the same? They are not the same. This has both negative sign and the digits 256. Both are under the power 1/4. This 1/4 only covers the digits. Negative is left out. This is just a traditional, this is understanding in math. If the power doesn't have a parenthesis, that means it only covers the digit parts, not the sign. So minus is left out here. This is what you have. Minus, power only covers 256. This one, minus is n. If the minus is n, yes, you were right to make this and say not a real number. But here we have minus out. This is out of business. The prison is only built for 256. 256 is inside prison, not minus. Minus is out. Okay? So you only put minus inside prison if you have a parenthesis including it. That's important. And this one, unfortunately, is what number multiplies to 256? 4 times? It's 4 times 4 times 4 times 4. 16 and 16 makes 256. It's minus 4. Alright? So be careful. Looks can be deceiving. Convention in math is if power doesn't have a parentheses, we leave out the minus independent from the power. So this thing is minus 4th index radical of 256. And 256 is a real number. And it's minus 4. Okay? Now, look at the difference. Do you see the difference now? Almost the same. 256 changed to 243, but where is the minus? Look at the minus. Minus is packed under 1/5. Packed under 1/5. I was gonna skip this question, I think, but no, I didn't. Okay. Let's do it. Since both minus and the digits are under the radical, under the rational exponent, we will put both of them with the guard being 5. I will go ahead and this time say not a real number. Are we correct? Are we correct? No, because this is an odd number. Odd numbers like negatives. Odd guards can treat negatives and get them out as a number. But what is that number? What number multiplies itself 5 times to 243? 3? Let's check. 3 times 3 is 9. 9 times 3 is 27. 27, 3, 81. 81, 3, 243. Yep, you're right. Is it positive 3 though? If it's positive 3, I got positive 240. This is negative, so actually when you see an odd number and negative value inside, you can pull it out. It's actually negative. Okay? So negative sign, if you have an odd index, you can move it out and compute a radical of positive 243 and don't forget to put that minus sign because we need to get a minus answer, so it's minus 3. Alright, I'm not typing it in. Alright, please compare number 4 to number 1 and tell me the difference, please. Here is number 1, number 4, side by side. What is the difference? Yes, we have a negative sign in the exponent. How do we take care of negative exponents? Okay, this is a new moment, new area. Because so far, number 1, number 2, number 3, none of the questions had a negative exponent, and this needs a brand new idea. We need to first fix the negative signs. Fix negative exponent first before anything else, before any conversion. Do you know how to change that negative exponent into positive? Anybody knows? Anyone? Flip it. What does flip mean? Which one will hit flip? We put 1. This is what flip it means. Put a ratio bar, fraction bar. Put this entire thing here with a difference. I put everything here with a difference. What did I change? I flipped negative also to positive. It's positive now. So I'm not showing anything, so it's positive. Do you see how I cured the negative? You need to first fix the negative sign. This is how you fix it. Alright, here is another exercise. How do you fix this? Tell me, somebody. How do you fix this negative? New question. I mean, this is not over, but I'm just checking if you learned this. Yeah, 1 over, repeat with a positive. Okay? How about chicken with a negative apple? It's not a chicken, that's a turkey. How do you fix the negative sign in front of apple? 1 over turkey. And where's the apple? Apple, but this time positive. Okay? So when you see negative sign in the exponent, that's what you do. Although no matter what you have inside, it can be x plus y. It can be chicken, it can be apple on the top, but if you want to flip the sign, you need to make reciprocal. Technical name for this flip is called reciprocal. Reciprocal. That's what they use. So don't be surprised next semester if you see the word instead of flip or chicken or turkey, and they say reciprocal. Oh, that's what it means. Okay. Alright, now we continue. We're not done here. We have a number raised to a rational power. We need to turn this into prison. How? Put the inmate into cell and decide the guard. What is the guard? 4. Are we done? We need to now compute this, because this looks like a rich inmate. He can bribe the guard and get out, right? So 16 really fourth root of something? I mean, is there a fourth root of 16? Is there a number that multiplies 4 times itself and makes 16? You already know it from here, right? It was 2. So the 1 over 2 is the answer. So what was the answer here? It was 2. So you can actually get this and flip it, 1 over 2. If you have a negative, of course, you're gonna get the reciprocal of this answer. Alright, so far so good. Any questions? Things are getting more challenging. Now, look at 1, 2, 3, 4. Well, I skipped 5. And compare 7, 8, 6, 7, and 8. You need to see a difference. If you're not seeing a difference between these questions and the past ones, you're in trouble. Do you see a difference? Yeah, don't read the definition. Don't read the yellow area. Just see the difference. What is it? In number 1 you had this 16 1/4. And in number 4 you had 16 negative 1/4. In number 2, I forgot, but 256 1 over 4. When you compare this, what do you see different? I see number, okay. I see fraction, ratio. I don't see any difference. Number, ratio. No, nothing. I'm clueless. What is the difference?
The negative sign.
No, we had negative signs before, look. Yeah. The top exponents do not have 1s all the time. These are 4, 3, 2. Look, earlier you had always 1, 1, 1. 1 over something, 1 over something, 1 over something all the time. The formula I gave you here works only if you have 1 on the top. Look, it's for 1 over n. What if you don't have 1 now? Something else. M over n, not 1. How would you do that? So you need a new formula. Here's how you do. Old formula, still the bottom number is your guard. N goes in front as a guard. Where does M go? This number go. You either put it all the way out or you put it right above the guard. I'm sorry, prisoner. Again, there are 2 options. Either way is fine. You can do both. You take n, put it outside as a guard. You take m, put it all the way out with a parenthesis, or put it right above a, right here. I prefer this way. Okay, I will be doing this way. Always keep m together with the prisoner in the exponent. You were actually doing it earlier as well. Look. You are sending this guy out. Where does 1 go? 1 is actually there. You just don't see it because a to the first power is a itself. Now what's the difference? Instead of 1 you have an m. So you're gonna make this m. That's it. That's the difference. Okay? Alright, so let's start solving these questions then. Number 1. Change this into prism format. 2 goes out, 1 in, 5 on the top. Am I right? Look, there are 3 numbers, 1, 2, 5, 1, 2, 5. I just put them randomly there. Yeah, I put them in the wrong number. Which 2 are wrong? 2 and 5 are in the wrong place. Always the denominator 1 is outside the guard. Numerator 2 is the power. Okay, let's compute this. What is 1 squared, by the way? What is 1 squared? It's 1. Still 1. Now guess a number. You multiply it 5 times itself. So you're gonna guess a number here. You multiply 5 times itself and it becomes 1. What number is that? 1. It's 1. Alright, let me give you a trick. 1 raised to anything. Anything at all. 2/5, 10, 1 million, negative 1 billion. No matter what crazy number you see here is always 1. So you could have just cheated and put 1 here at the first place, but I just wanted to show you, okay? Is a real number 1? Alright, that was easy. Number 6. I picked number 7 first because it's easy. Number 6 is not so easy. First, are we ready to change to a prism format? No, because of what? Negative needs to be cured. Cure this. How? By putting it under 1. And it becomes 25 raised to the power 3/2. Positive 3/2 now. Alright, next. This is positive exponent. I can now make it into a prism. 25 is our inmate. What is the power of 25? Guard is square root. If it's square root, you may skip writing it, okay? But I will put it anyways. Okay? Alright, here is the way I prefer to do this. Because I know 25 is a nice number, and cube of it will be triple 25. Right? There are 3 triplet inmates. They are identical, cloned, and they all wanna escape. Do they escape? Is there a number that multiplies itself to 25? This is square root. It multiplies itself to 25. Any number? 5. Any number multiplying itself to 25? Yes. This comes out as 5 as well. So this is actually 1/5, 5, 5, which is 1, 25. Okay? You know what? This is how book does it, okay? But I want to show you an alternative way. Are you ready? I want to show, but know this way too. Just break this power into each identical terms and then let them escape. Figure out a number whose square is 25, 25, 25, and 555, and we're done. 125 is the answer. Let's first try that. Wait a minute. Oh, this is 6. Is a real number, and we got it as 1 over 125. Check. What is the second way? So I'm going to back this up and try this. But you don't know this yet. You don't know this trick yet. But after 15 minutes later, you will learn it. So I'm just giving you a heads up preview. All right. 25 is a square of a number, right? If you have a big fat number given like this, 25, 27, think if it's a square or power of a basic number. 25 is a square of 5. And then we have a minus 3 over 2 outside. Okay? This is an alternative way we will learn in 15 minutes. I'm just giving you right now. Next, this is the situation of a double power. There is an exponent and another exponent following it, another exponent. What do you do? How do you combine if there are two exponents chained to each other on the same base? How do you combine them? What operation do you do between them? Do you add them, subtract them, multiply them, divide them? You have 1 out of 4 chance. Pick one. Add, subtract, multiply, divide. Which one? Which one do you think makes sense? There are two exponents, 2 and minus 3 over 2, around 5 now. I turned 25 into 5 squared. I need to combine these two so I can operate with prison rule. What do I do with 2 and minus 3 over 2? 2 and minus 3 over 2 must be?
You multiply, so you can cancel the 2.
Yeah, we multiply them. Look, most of the time I hear the answer we add them because it looks like two powers come together, we must add them. No, the right operation is multiplication. We multiply them. And when you multiply them, look what's happening. This is now only minus 3. You have a single power minus 3, but negative. So I cured the negative by flipping it. Look what happened. Same answer, 555, which is 125. Isn't this neat? We didn't have to turn this into prison and let escape prison. No such story required. This is the benefit of knowing couple rules coming up. I just gave you a preview of these rules, but you don't know them yet, I assume. So I will still keep doing these questions with the regular way, prism method. Okay? So we're done with number 6 in 2 solutions, 2 different methods. Let's do number 8 now. Alright, first we need to fix the negative power. Cure the negative. It turns into 1 over 27 positive 4/3. What happens to this minus sign? Are we going to put it right here again? You may keep it here, or you may pull this in front and keep it all the way out, or you may even pull it to the top. It's okay, either side. 1, 2, 3 sides are okay. So I will leave it right here then. So I'm leaving minus here out. I'm only focusing on this part, which is this guy. Okay? Next, let's convert into a prison cell. Because that ratio means, rational exponent means, it's a radical with 27 inside, 4 on top, 3 out. And this means there are 4 inmates in this prison cell. 27, 4 times itself, but everybody is protected by the same guard. 3 is keeping them inside. See if they can break prison. Can you let 27 out? Is there a number multiplies itself to 3 times and make 27? Is there? What number is that? 3. This comes out, that one comes out, everybody comes out here as 3. How many times though? 4 inmates coming out as 3. So they combine into 81. Okay? Are we good? Is a real number. I made a mistake and everybody's sleeping. I said 1 over 81. But it has to be negative 1 over 81. How did I forget that? Oh, no, I didn't. Sorry. So I didn't forget it. Okay. I forgot to put it here. That's it. Okay, one more question. What is different here on number 9?
Fraction.
It's a fraction. Fraction. For the first time, the base is not a number but a fraction. But the idea is the same. We need to cure this minus sign. Usually, if you have just a number raised to negative power, you flip that number like that. We never flipped a fraction. How do you guys cure fraction negatives? If it's a whole number, this is what you do. But this is not a whole number. It's 4 over 49. How do you cure it? How do you reciprocate? What is the reciprocal of a fraction? Look, reciprocal of 4, reciprocal is 1 over 4. But how about 4 over 49 reciprocal? Yeah, you make it upside down. Because technically 4 is not just 4. There is a 1 hiding underneath it. When you are reciprocating, you are flipping this. 1 over 4, it becomes 1 over 4. That 1 becomes visible. So here you already have both sides visible. When you flip it, it's 49 over 4. So the way you cure 4 over 49 is make it 49 over 4 with the positive power. Do you understand? Do you understand? Good. Now figure this number out. The first person doing it gets credit.
got 343 divided by 8.
333?
343.
43. Divide by 8. Any different answers? No? Alright. First, I make a prism for it, but our inmate is whatever entire thing under the power. It's 49 over 4. Who is the guard? This is the guard. There is a number left over on the numerator, so it goes to the top. But what this does is, by the way, you have it like that. It just triples this ratio under the prison. So yeah, there are 3 inmates, 3 brothers, identical brothers, in the same prison. 3 of them. So you just need to get all of them out. That's it. Under this square root. If possible. If not, they will be locked in there. So is there a number? This is square root, means pick a number, multiply by itself, it's gonna make 49 over 4. What number multiplies itself to 49 over 4? It's a ratio, it must be a ratio. 7 over 2. So these are 7 over 2's 3 times. So that's it. 7 over 2, 7 over 2, 7 over 2. I think when you multiply 777, you get 343, right? Agree? And 8. Yep, she's right. Alright, in number 10, you're seeing something for the first time. What do you observe? Something new for the first time in number 10? A variable. C, a variable. A letter. So you won't be able to get a number in this expression. You're gonna simplify it, change it in the radical, and simplify as much as you can. Your answer will have some C left out in the answer. Alright. Let's focus on this. What we need to do. It just says conversion. This is a very simple question. Convert this into prism. But focus on, please look at who prism covers or captures. This is the prism maker, and it's about only which term? What is it about? What? 9? No, it's about only C. Look, this only covers C. This is above C. How do I know it's not covering 9? Because we don't have a parenthesis. If you have a parenthesis, both 9 and C must be going into prism. This 3 over 8 is only above C. It doesn't have 9 under this. So only C is in this prism. 9 is out. Just like negatives, coefficients, numbers in front of variables are independent from the exponent. They are out of the business. They are out of the prism. Do you understand? So when are they in? If you have a parenthesis and they group number and variable under the exponent together, then we put both into prism. But that's not the case here. Alright, this is incomplete yet. What is the guard? 8. It's not 3. What is the power of C? How many inmates do we have? Triple C's. Do you need to write CCC here? Not necessary. Unless they are coming out, you don't have to. We did it here because it was numbers. Here you don't have to. Triple C will stay triple C. They won't break prism. So this is it. This is the final answer. 9. 8 index radical. C cube is as much as you can get here. Okay? Are we good? you know how to make different indexes, right? This is what you use. First type in the guard 8, go in and make C raised to power 3. Alright. Change this back to exponential expression. You need to change this into exponential. So it's backwards. Here you had some expression in exponents. We made it prison. Here you have a prison. You need to change the exponential. Make exponent. And this is a 2-second question, please. Anybody?
X to the third.
Yep. Write x. Power is going to numerator. God is going to denominator. All done. All done. To make a rational exponent, use this first. Choose the top 2, bottom 3, check. Alright, now we are starting a whole different business. First half was to get you to this part. We introduced the relation between rational exponentials and radicals, prisons. Now I'm going to show you how to combine multiple exponents, how to add, how to multiply 2 or more rational exponents, how to divide them, how to pass power to division, how to pass power to multiplication, and all bunch of other rules. So I'm not expecting you to memorize all this, but by applying into questions, these should take place in your mind after a while, okay? Not on first sight you will memorize all this, but by applying one by one, hopefully by the end of the section, after the homework you completed, you will understand when to use and quickly without using this sheet. But keep this sheet on the side when you're working for first several questions. So let's understand what this means. It says if you have two exponential, if you have two exponentials with different powers but same bases, do you see the same bases here? So this is a must. You must, base must match, AA match. Then all you need to do is you add the tops, such as x to the 1/3, x to the 4/3. You only add 1/3 to 4/3, which makes 1 plus 4 is 5, 5/3. That's your new power. Okay, does it make sense? Second, what if you divide same base, different powers, same base, AA, different powers? All you need to do is subtract bottom power from top one, such as 3/5, 1/5. You subtract them. 3/5 minus 1/5. What is 3 take away 1? 2. Denominator is 1. 2/5. That's it. We have already seen this. This is called double exponent property. I call it double exponent because there are two exponents here. We have done this in this question here. I said this is 5 square and then 3 house, and I multiplied these two and combined, right? That way. So it's here. If you have two exponents, m and n, you multiply them. Like 1/3 and 1 house, 1/3 and 1 house, you multiply across, 1/6 is the answer. Does it make sense? Next, this is a single power, but it has double base, 2 items. Or it could have been 3 items, A, B, C, or 4, A, B, C, D. But they are all multiplied, so you can pass this power to each of them. Look, A has its own power, B has its own power. So you're copying the power to each and every term inside. But that's only true if things are multiplying inside. Here one example. Okay, this is a very common mistake, guys. Here I can pass the square to both and make this 2 squared times 3 squared. What is 2 squared? 4. 3 squared. 9. 4 times 9 is 36. Alright, let's compute this directly. What is 2 times 3? What is 6 squared? Do we have a match? Yes, because I applied the rule properly. Everything was multiplying, so when you are multiplying, you can pass the square in. What is wrong here? Most people do this. Oh, I need to pass the square here. And they get 2 square is 4, 3 square is 9, they get 13. However, 2 plus 3 is 5, 5 square is 25. Wait a minute, this is 25 but you found 13? How is that possible? Because you did it wrong. You cannot pass the square if it's a plus or minus. Plus and minus is bad. Multiplication or division is fine. You can pass to division as well. If it's 2/3, you can pass it to the top and bottom because division is fine. Multiplication, division, okay. Addition, subtraction, bad. Most common mistakes is happening in these. You guys square this by squaring each. Wrong. Wrong, wrong, wrong. Because this is a subtraction, just like here. You cannot pass the square. Here you can. This is fine, correct. You can square each and make x squared and 9 or 3 squared, and this is 9x squared. This is correct because it's multiplication. If it is subtraction or addition, no, don't do it. How can you square a sum then? You need to FOIL it, double it and FOIL it. Alright, let me finish this list and we will apply them tomorrow, okay? Again, I already mentioned this. If you have a division, you can pass the power to both terms. A has its own m, B has its own m, like this. 4 to the 1/2, 25 1/2, and you compute these later and get 2/5. That's not our concern. Can you pass it? Yes, we can. Okay, we have already seen this, but I always skip the middle step. You don't have to do this. If you have a negative power, you need to cure it. Curing procedure is you just put it under 1, right? We have already seen that. Like negative 1/3 is 1/8, positive, well, no, not that one. Not this. It's 1/8 to the 1/3, and that becomes 2. I always do it this way. Turn this into 8 with a positive power. By the way, this is a good fact to recall all the time. Any number raised to 0th exponent, 0 exponent is always 1. Like 5 to the 0 is 1. 2 to the 0 is 1. 10 to the 0 is 1. They didn't mention it here, but it's worth mentioning. There is an exception to this. What is 0 to the 0th? Yeah. Nobody knows what this thing is. It's undefined. So this is a mathematical dark room or dark area. We don't know 0 to the 0th. But anything else is fine. Minus 5 to the 0 is 1. 100 to the 0 is 1, etc. Okay? So on Friday we will continue applying these. So why don't you start from tonight and do these on your own first. So you can, because these are challenging to apply if you don't practice.